Google just solved the biggest problem in robotics. Typically, robots are designed to be pros at doing a small finite set of tasks. They thrive at performing tasks in which they are specifically programmed. But once you give them a task they are not familiar with, they often fail spectacularly. In fact, it is a common theme in sci-fi movies to defeat robots by confusing them with problems that are beyond their capacity. Sparks start flying out of their heads as they short-circuit and explode. In this video, we're going to talk about how Google DeepMind created a powerful general-purpose robotics model called RTX that enables a wider range of tasks more efficiently than any other existing framework in the market. They used a novel training technique that allows robots to become self-taught machines. Since robots are often exceptionally good at performing a specific task, but suck at another task a different robot may excel at, wouldn't it be awesome if robots could somehow teach themselves? How would you teach a robot to educate itself on new tasks it hasn't been programmed to perform? That's exactly what Google DeepMind did with a mechanism they called X-Embodiment. Google released a paper titled A Central Lesson from Recent Advances in Machine Learning and Artificial Intelligence, which introduced this new robot learning concept. Training datasets are the building blocks of a robot's intelligence, and X-Embodiment is a kind of social hub where robots from all parts of the world can meet and share training data. Feel free to call X-Embodiment a learning institute for robots. But they didn't do this alone. Google got several academic labs from across the globe on board with the project, and together they collected a wide variety of high-quality training datasets from 22 different kinds of robots. You may or may not know, but one robot typically has 20 skills. A single skill usually entails 3,000 different tasks. Now multiply 3,000 by 30. That's the number of tasks an OpenX-empowered robot can perform. That's 90,000 for those who may be wondering. Mastery of a skill also typically means that a robot can perform 15,000 tasks in a million different scenarios. While we are talking about the numbers, I want you to understand that it's not just about the quantity. X-Embodiment is also about quality and diversity. The ingenious dataset contains a rich variety of tasks, from simple things like picking up items and moving them around, to more sophisticated tasks that require advanced cognitive capabilities. X-Embodiment is by all means a super dataset. So instead of building a robot from scratch and adding the capabilities of every existing humanoid, Google decided to create a shortcut for robot builders. A platform where they can share training knowledge instead. How smart is that? X-Embodiment is a typical example of working smart and not hard. Please know that I'm not trying to downplay the efforts of Google DeepMind and other academic labs involved in the project in any way. Creating the platform for this robot-like commune is no simple feat. It's so much of a big deal that Google couldn't embark on this project alone and instead collaborated with 22 other academic labs to make the X-Embodiment dataset possible. This initiative turns robots into self-taught entities. Developers don't have to reinvent the wheel and can easily expand on existing knowledge from other creators to build robots that can adapt to various scenarios. One can see how this new pathway that Google and its helpers have forged for the future of robotics will accelerate the development of this already fast-moving field. Let's see how developers have leveraged this rich resource. The RTX model is a miracle child born out of the conception of two robust Google models, RT1 and RT2. Both of these are now supercharged after receiving training from the rich and diverse X-Embodiment dataset. The Proficiency RTX has showcased proves that OpenX is indeed a rich resource for building general intelligence like robots. One element you can't ignore from the huge success of the previous RT models is the transformer architecture. A transformer is a deep neural network model that uses a mathematical technique called self-attention to understand what a set of data, usually in the form of an array of vectors, has in common. Google first developed transformer models in 2017, and even today it remains the most powerful architecture in the machine learning community. In 2021, the influence of this framework in the AI realm was so far-reaching that Stanford had to recognize it in a paper where they dubbed it the foundational model, because they believe the future of artificial intelligence rests on transformer neural networks. Under the hood, the RTX robotics model is stacked with layers of transformer neural networks that allow it to focus on the most important data points in vast streams of input data. That way, the machine goes through tasks with a high level of self-awareness. Cross-modal learning is a type of learning that occurs when a robot picks up new information from more than one modality. An RTX robot would have several sensors to help it experience its surroundings, like odometry sensors for detecting movement, laser rangefinders for sensing distance, and cameras for seeing objects. Cross-modal learning happens when the model realizes something new from more than one of these sensors. For example, the texture of a ball. It can infer that the ball has a rough texture by sensing its rugged surface and seeing the grooves on its body. When you think of it, that's exactly how humans learn. This enhanced method of robot learning doesn't just make RTX better informed to perform tasks, but it also sets the tone for how robots will assimilate in a not-so-distant future. The RTX robot model certainly implements some interesting techniques. Let's see if the new formulas help it perform better than existing models. They ran in-lab tests on RT1X and compared its output with earlier robot models across 5 different research labs. The results were shocking. On average, RT1X completes tasks with a success rate of 50% in comparison to other existing robot frameworks. Moving on to RT2X, the results were even more astounding. After integrating several robots with the RT2X model, their performance improved by 300%. From the outcome of the test, it's safe to say that the Open X-Embodiment project gives robots enhanced cognitive abilities and the finesse to execute tasks. It also enables them to adapt to new situations that would have left them clueless in the past. RTX also beat expectations in academic tests. It smoked other established models, scoring higher than 50% when evaluated with different kinds of professional examinations. All in all, the lesson here is that Open X-Embodiment training is bringing the field of robotics closer to general intelligence than any other training initiatives that have come before it. Integrating large data sets from different kinds of robot platforms allows robots to transfer skills, resulting in more general-purpose robots. I hope you enjoyed this video. Please remember to like and subscribe.